Okay. Yeah, so this is, again, Chapter 8, Section 7. We're doing systems of equations, but they're not going to be lines anymore. These are nonlinear. And so we have x squared minus y equals 4, and we have x squared plus y squared equals 4. And so I think it's pretty clear to you guys by this point what Emily said, that this is going to be a parabola. Why? Again, because the y is not squared, but the x. By the way, which way is this parabola going to open? Is it an up-down or a left-right? It's an up-down. And it turns out it's up, because if you solved, you could write this, say, as y plus 4 equals x squared, right? I mean, that's one way to write it. Okay, so it's definitely an opening up parabola. Now, what about this one? X squared plus y squared equals 4. That's a circle, right? Center. We have the center is 0, 0. And the radius is 2. Okay. So now what I'd like to do is I'd like to think about what this problem looks like. Well, I could actually graph the circle, right? I could sketch a graph of that circle. So I don't even need graph paper for that. I have, you know, it has radius 2, and it's centered at 0, 0. So the circle looks something like that. A little more round, but something like that. Now, what about the parabola? Well, you know what I'd say about the parabola? It is almost this parabola that I'm so very familiar with. Y equals x squared, right? I mean, y equals x squared, I know goes through negative 1, 1, and 1, 1, and then it goes up to 2, 4. It's almost that parabola. The only difference is, well, what does this tell me to do? Maybe it's easier if I make one more step and if I write it this way. If I write it as, the way we used to write it back in chapter 2, I think it was, y equals x squared minus 4. There you go, guys. What's that tell me about the parabola? Shifted which way? Down. How far? 4. So you know what? This parabola is the same as the one I drew in pink, but I have to go down 4 places. So there it is. There it is. Well, I guess it would go here and here. But, I don't know, can you tell where it's going to intersect? See, it's funny, because I can see a couple of points that I can tell are on the circle and also on the parabola. But it's hard for me to tell from the picture whether the parabola crosses the circle or it doesn't. Maybe it's just tangent, like that picture that Delaney drew for us today. Or maybe it intersects a couple places. But because of symmetry, whatever it does on one side, I would expect it to do it on the other. Do you guys see why graphing is limited here? What we want to do is we want to try and solve it algebraically. And we want to use some of the techniques that we talked about last time. Now, when we talked about linear systems, what were some of the techniques we had for solving systems? Well, there was graphing, but what else was there? Yeah, we have substitution, and we have elimination. Those are both valid still. Okay? I think the emphasis is probably going to be on substitution in this section. But both methods are valid. And I'll be honest with you, as I'm looking at this one, I would right away think, oh, I may want to do some elimination. Because what do you notice about that system of equations? Yeah, you have x squared, you have x squared. You have negative y, you have plus y squared equals 4 equals 4. I guess if I wanted to, I could multiply one of the equations, maybe the top one, by what? Negative 1. So let's rewrite the system. If we multiply the top equation by negative 1, I get negative x squared plus y is negative 4. X squared plus y squared equals 4. Okay? And now if I add the equations, what happens? Yeah, we're going to get some stuff disappear, right? It's going to say, well, negative x squared plus x squared, that's 0. So I get y squared plus y equals 0. Y squared plus y equals 0. So now let me see what happens. If I factor out a y, I get y times what? Y plus 1. And so this tells me that y could equal 0. By the way, that's what I was seeing on the picture, that it seems like they're going to intersect at y equals 0. And this tells me something else could happen. This tells me that y might equal what? Negative 1. Now, I have y equals 0 or y equals negative 1. What do I do next? Yeah, I have to substitute back into where? Which equation? It actually doesn't matter, right? Let me prove it to you that it doesn't matter. Well, let's do it both ways. So I'll tell you what, if you guys are in the last two rows, could you guys take this first equation, and I want you first to plug in y equals 0 and see what that tells you. And then I want you to plug in y equals negative 1 and see what that tells you. And then people in the first two rows, we're going to play the same game but with the other equation, the equation of the circle. We're going to first plug in y equals 0, then we're going to plug in y equals negative 1, and we'll see what it tells us. It seems like people are starting to understand what I'm saying. If I have y equals 0, and if I plug it into either equation, so say if y equals 0, we get, well, x squared plus 0 equals 4, so x squared is 4. So what does x equal? Plus or minus 2, right? That goes along with y equals 0. And same thing's true if you use this one, right? You still get the same exact equation. Now, if y equals negative 1, then I get x squared. See, this would become plus 1, right? Because it's minus y. And that's the same thing they get in their equation. Equals 4. So x squared equals 3. So what does x equal? Well, plus or minus radical 3. And so I'm going to put those together also. And so now I really have an idea, a better idea of what this picture looks like. Okay? Let me put it this way. Do you think it looks more like what I drew on the left or more like what I drew on the right? Well, we're about to see. And I claim it looks more like what I drew on the left. Here, let me draw it again down here. Okay? So I'm going to start by drawing a circle. There's my circle. Center 0, 0. Okay? What, Amanda? Thank you. Thank you. I take pride in my circles. All right, so now I'm going to draw the parabola. What's the vertex of the parabola again? It's not 0, negative 2. I think it was 0, negative 4, right? So here's 0, negative 4. That's the vertex of the parabola. And what we just learned is we learned some different places that we have points of intersection. Okay? Now look over here. This calculation tells me that one point of intersection is at 2, 0, and another point of intersection is at negative 2, 0, right? Because x is allowed to be plus or minus 2 when y is 0. Does that make sense to people? Okay. Now the other thing I learned, say from over here, is that also y can be negative 1. It's not going to be negative 2, but it might be negative 1. Here or here, I'm going to have some intersection points. What are they going to be? This one is going to be square root of 3, comma, negative 1. And this one is going to be negative square root of 3, comma, negative 1. Does this make sense to people? And so you can see now that the parabola does intersect the circle in how many places? 4 places. And then it kind of curves up after that. Now the thing I didn't show you is a substitution. You can also solve this same one with substitution, but maybe I'll do that for the next one. Okay, kind of show you how that looks. We used elimination here. So we have this system. X squared plus y squared equals 16. And we have 9x squared minus 16y squared equals 144. And so what shapes do we have? Yep, we can tell that right away, that this is a circle because, well, how do you know the one's a hyperbola? Maybe that's easier. You have a negative. I guess the only question about this one is it a circle or an ellipse? They're almost the same thing. They have the same sign on the x squared and y squared terms. And the reason it's a circle is because you have the same coefficient. Okay. So, I guess I could start to draw it. Well, before I start to draw it, I better rewrite the equation, okay? So again, we have x squared plus y squared equals 16. But I want to rewrite the hyperbola because I want to set it equal to what? 1. Now, after you take college algebra, you learn a very important math fact. 9 times 16. That's not one you knew before, but I'm telling you, after you take college algebra, you're going to know it. 9 times 16 is? It is 144. It just shows up all the time. Because, well, here's 3 squared, and here's 4 squared, and 144, of course, is 12 squared. So it's 3 times 3 times 4 times 4, or 3 times 4 times 3 times 4, however you think of it. Anyways, when I divide everything by 144, what do I get? I get x squared over 16, because the 9's cancel if you want, minus y squared over what? 9 equals 1. Okay, so this is a nice, what I did? I divided. I wanted to get it set equal to 1. So basically what I did was I took the equation and I divided everything by 144. Make sense? And then it just turns out that both 9 and 16 go into 144, so it works out really nice. This is kind of a nice problem. I want graph paper for this one. I'm going to pause for a second. So if it's me, I'm going to graph the hyperbola first, because I think that takes a little more work. Bless you. So let's see what we want to do here. Well, I'll draw some axes. Well, maybe I'll draw the circle. That's easy. X squared plus y squared is 16. Where's the center? 0, 0. So we can come out to 4, 0, or 0, 4, or negative 4, 0, or 0, negative 4. And so if I had a circle through those 4 points, something like that. Now the other one, the hyperbola, let me work out what that looks like. I'll do that in black here. So the first thing I do is I go and I look for A. A squared is 16, right? And that tells me A is plus or minus 4, right? So I'm going to come out 4 in the x direction. See, what I'm doing is I'm drawing the rectangle that's going to help me get my asymptotes. And then B squared is 9, so that tells me to go up and down how far? 3. And so you want a rectangle that goes 4 in either direction and 3 in either direction. Hey, this is Delaney's picture. Right? Well, I don't know if you can see that yet. I can. I'm trying to graph this hyperbola. So what points, can you name a point on the hyperbola? The one that comes to mind for me is you let x equal 4 and y equals 0. Because then you get 4 squared over 16 minus 0. What's that equal? That's 1, right? So do you guys see that that's a solution, 4 comma 0? Well, I'm trying to plot the hyperbola. Find C. What's C going to give me? The focus. I could plot the focus. Let me ask you guys something. Is the focus part of the hyperbola? It does tell you, I guess, which way it goes. I already know which way it goes, actually. The way I know which way the hyperbola goes doesn't have to do with C. It has to do with the fact that the x squared over 16, that's the one, the term that's positive and gives me positive 1. So in other words, I think of what could I put in for x that'll give me the 1. And it turns out 4 comma 0 is a point on the hyperbola. Can you give me another point on the hyperbola? Negative 4, 0 is also a point on the hyperbola. Now I'll tell you what some people might try. You might say, hey, let's let x equal 0. 0 minus y squared over 9 equals 1. But do you see that this is not going to work? How come? Well, because y squared has to be positive, right? And we're going to get negative something equals positive 1. That's not going to work. Do you guys see that? Well, provided that we're keeping it real, which we are. I have a great book called Conics in my office where they allow you to put imaginary numbers in. Beautiful things happen. We're not going there. All right. So no, this has no solutions, right? So I guess what I'm saying is, what did I just do when I graphed the hyperbola? When I set y equal to 0, I get 2 solutions, and so there are 2 x-intercepts. But when I set x equal to 0, there were no solutions, and that tells me there are no what? Y-intercepts. And if there's no y-intercepts, now I know which way the hyperbola goes. Okay? So to finish the picture, let's do this. Let's plot the dotted lines that are going to be the... Oh, wait. I see I screwed up. I made the bottom part of the rectangle go too far. It's more like that. The top one's okay. I missed the bottom one. The bottom one cuts through that circle. So, okay. I'll try again, guys. I'm trying. The bottom... I'll do it in pink for the asymptotes. One asymptote looks like this. There we go. And the other asymptote looks like this. See? The rectangle goes up 3 and down 3. It goes up 4, left 4 and right 4. And so the hyperbola looks like this. The hyperbola looks like that. You guys follow? All right. So now what do we do? Well, now, we're supposed to find the points of intersection. Can you see them? How many are there? There's 2. Now, that's fine and dandy. But just because I can see it doesn't mean I believe it. This is solving it geometrically. I would really like to solve it algebraically. And I promised you a method called substitution. Okay? So, how does substitution work? Well, I'll tell you that for substitution, first piece of advice I'm going to make is that you write the equations next to each other instead of in the way they were. Let's take the original equations. X squared plus y squared equals 16. And the other equation was 9x squared minus 16y squared equals 144. Now, you notice in this problem, it's not like the parabola problem. I don't have any y that just is sitting there by itself. But I'm going to do this. This might occur to some of you. Y squared equals 16 minus x squared. Right? And then, some of you would be taking the square root of both sides. Don't do it. You don't need to. Because, see, this tells me what y squared equals. You see that? So I'm going to come over to this equation, and where it used to say y squared, do you know what I'm going to throw in there? 16 minus x squared. So watch what happens. We get 9x squared minus 16 times, and we put in parentheses that 16 minus x squared. Does that make sense to people? No, that's my point. If I had written down what y equals, then yes. I mean, you're right, because normally we have to do that, but actually what I'm substituting for in this problem is the y squared. So that's new to you guys. It's a trick that's very helpful, because now it makes the equation a lot easier to solve. 9x squared minus, let's see, 256 plus 16x squared is 144. So 9 and 16 is 25. 25x squared is equal to, well, I need 144 plus 256. Hey, that works out pretty nicely. What do you get? Isn't that 400? Nice. So x squared, let's see, 400 divided by 25. How many quarters go into $4? 16. And so sure enough, I get x equals plus or minus 4. Now, once I have those solutions, x equals plus or minus 4, what am I going to do with them? Go back whence you came. All right? And so I have y squared equals 16 minus 4 squared. Right? By the way, you might also have y squared equals 16 minus negative 4 squared. But do you see that you're going to get the same thing? Because you're squaring it. So you're going to get y squared is 16 minus 16. Y squared is 0. So what does that tell me? Y is 0. And that's why we only get two solutions. The two solutions are the solutions I showed you on the graph earlier, right? So this is 4 comma 0, and this is negative 4 comma 0. I like this section because I think that by doing this homework, you guys are actually going to get stronger at Chapter 7. You know, that's part of the point. So I think this is a good thing to do. There's some inequalities to do. I don't want to do that. I do want to do one more problem. And I guess I just got to decide which one. Number 8? Yeah, possibly. I don't want to do them today, because I only have like 5 minutes left. Tell you what. Let me pause the last problem. So we have 4e to the x plus 3e to the negative y. By the way, if any of you were planning on turning homework in, why don't you pass it up now while we're wrapping things up. Equals 1. Just throw it right there. And 3e to the x plus 2e to the negative y equals negative 1. Okay? So this is kind of weird because this equation is very different from the other ones. You guys with me? I don't even want to draw it. When I said draw a sketch, I don't want to right now, okay? I have a small idea what it might look like, but it's very small. Okay? Well, yeah, we're going to need natural logs at some point, aren't we? Okay? But I guess the point is that you can solve this using the same kind of techniques that we've been using. I mean, if I wanted to, I could write 4u plus 3v equals 1 and 3u plus 2v equals negative 1. Would you be able to solve this pink system for u and v? Sure. I mean, that's a linear system. That's like the kind we did last class. And then you could put the e to the x back in and the e to the negative y back in if you want. Okay? So that's kind of the helpful hint of what to do. I guess if it were me, I wouldn't even write the pink. I would just kind of do something like this. I might multiply the top one by 2. 8e to the x plus 4, 3 times 2 is 6e to the negative y equals 2. And maybe I'd multiply the bottom one by negative 3. Negative 9e to the x minus 6e to the negative y equals, now wait, I got to be careful. Negative 3 times negative 1 is positive 3. And I would do that so when I add, I get negative e to the x. The e to the y's are gone, equals 5. So e to the x is the same as what? Negative 5. And then you can go back and substitute to get the y. But the other thing I'll tell you is, what does x equal? The natural log of negative 5. That's undefined. What? A stupid problem. No solution. All right. Happy Thanksgiving, guys. I mean, if I'm going to go ahead and graph that, let's see. I'm going to graph this thing in green again. Kind of like that last time. So, all right, let's draw the coordinate plane. And I want the center of my circle is where? 2, 0 is my center, right? That has a center of 2, 0. And what's the radius? Radius is 1. By the way, this is something, the reason I'm doing this example is because you notice it says less than. It doesn't say less than or equal to anymore. And you remember what that meant on a sign diagram. It meant you'd have an open circle instead of a closed circle. You guys remember that deal? Some do. All right. See, in the last problem, we were allowed to equal, and that happens right on the border, right on the curve. Here, I'm actually not allowed to equal, and the way I'm going to signify that is I'm going to put a dotted circle. And this is going to say, hey, none of these points are solutions. Oh, wait, that's wrong. What did I do wrong? The radius is supposed to be 1, so it looks like this. It's the inside circle there. That's what I'm looking at. But I'm going to make it dotted because none of those points are solutions. Okay? So if you have a less than symbol, you want to make it dotted. All right, time for the other one. The other one, let's see, what's it look like? We have, well, x squared plus 4y squared is less than 4. What shape is that going to be? That one's an ellipse because the coefficient of x squared is different than the coefficient of y squared. As soon as I know that's an ellipse, I'd recommend that we set it equal to 1. So let's go ahead and, what am I going to do to both sides? Divide by 4. So I get x squared over 4 plus, well, the 4's are going to cancel, so I guess I'm going to get y squared over 1 is less than 1. So that's nice. Okay, where is the center of this ellipse? That one's centered at 0, 0. The h and the k are at 0. So that's my center. Is this one a thought or a fog? It's a fog. It's on the ground, right? A squared is 4, so I can go out 2 in either direction. That's my major axis. B squared is 1, so I can go up and down 1 in either direction. So I'm about ready to sketch the ellipse now. I'm going to use a dotted line. Again, for the same reason, because this is less than. When this is equality, that's going to be right on the ellipse. So we're talking about points that look something like this. Are you with me? Okay. So again, you have to ignore the bigger green circle. Now, I'm trying to find the solution set. Okay, so let me take the circle first of all. We have x minus 2 squared plus y squared is less than 1. Can I use 0, 0 as a test point? I guess I can. Remember, it's not this one. It's this one right here. So 0, 0, is that a point? That would be a point outside the circle. You guys with me? So let me try it. That's my test point. 0 minus 2 squared plus 0 squared. Is that less than 1? True or false? What do you guys think? Yeah, I'd say that's false. Because remember, this is going to be positive 4 less than 1. That's false. So we're going to be inside the circle. Right. So the shading doesn't happen outside the circle. It's inside the circle. Well, it's funny because the solution to the system is only going to be part. No, it'll always be either all of the inside or all of the outside. Just like for a line, it'll always be all of one side or all of the other. Okay? Now when you have a hyperbola, that one gets a little more interesting. You might want to test a few different points because you're going to see a few different regions. But you'll learn pretty quickly what always happens. Okay. So now let me think about the ellipse. Well, same deal, right? We could test 0, 0 and see what happens. 0, 0 is inside the circle. So let's try it. 0 plus 0 less than 1, what do we say? True. So where am I shading for the ellipse? I'm shading in here, right? So now if I ask you, what is the solution set? Well, the solution set, again, I want dotted lines around these curves, but I want the double overlap. That's the solution set right in there. The region where the inside of the ellipse overlaps with the inside of the circle. That's going to be the points that form the solution set for this system of inequalities. All right? So I'm working on page 646, number 26. So we're doing a system of inequalities. X squared plus y squared bigger than or equal to 25. Y minus x is less than or equal to 1. So if I'm going to draw a picture here, let's say these are my axes. So let's see. I know if that said equals that first inequality, it would be a circle of a radius 5. I'm going to go ahead and sketch that. Here's my center 0, 0. So let's see if I go up 1, 2, 3, 4, 5. And I'll sketch it in green. At that point, that point, that point, and that point. So there it is. And now, let's see, I'm going to use this purplish color here. This inequality we can rewrite as y is less than or equal to, well, x plus 1. Right? And that's the kind you guys have done before. You've done linear inequalities for sure. So how do you graph this? Well, first we graph y equals x plus 1. So I'd graph this y-intercept, right? That's 0, 1. And then what would I do? Yep, the slope is that, 1, so it looks something like this. And so, well, actually, very interesting. I think the circle's supposed to go right through that point right there. And right through this point right here. But anyways, we'll talk about why I know that in a minute. So I claim that my magic points of intersection here are 3, 4, and this one would be -4, 3. I think those are the nice points of intersection that I would get. We'll talk about why in a minute here. But the point is that this is the picture if it said equals. And now we have inequalities. All right? I want you to think back to at some point when you studied this kind of a problem. What is it you're supposed to do if it says inequality? What do you have, Jenna? A sign diagram we did quite a bit, right? So that we could do what? Why did we do sign diagrams? Well, see, back when we were doing inequalities in this course, we had a number line, and we would find the places where it equaled 0, and then we would test if the sign diagram was positive or negative. You guys remember that? Okay, so we did that. And the whole point was, let's suppose you had it greater than 0, then you would be shading certain intervals. You guys with me on that? But all this was done when we had one variable. Well, now I'm in a different situation. I have two variables. What's that? You can do that. That's how you could find these points of intersection. You're right. So, yes, how do I know that 3, 4, and negative 4, 3 are the answers? I guess one way to get it would be, and this is what we've been doing, if I'm thinking about the equations, x squared plus y squared equals 25, and then since we know that y equals x plus 1 is that line, like you said, I can substitute in. Okay? Work it out. I'm not going to work it out right now. I'll just tell you, if you solve, how many solutions do I expect I'm going to get? 2. You're going to get x equals 3, which is this coordinate right here. That's the x coordinate. Or x equals negative 4. And by the way, once you get x equals 3, how do you get the y coordinate? Where? Yeah, but what I would do is I'd go back to this equation, see? 'Cause it's so easy then. If x equals 3 and I go back to this equation, what is this going to tell me now? Y equals 4. So that's really nice. That's the trick, okay? Is I knew that the line, right? This is the inequality, y less than or equal to x plus 1. But all I've done so far is graph y equals x plus 1. So algebraically, where it used to say y, I can put in x plus 1. Which numbers? And you saw that it worked. Yeah, well, I said, well, how do you come up with that? Jenna said, well, we can do this to come up with it. Okay, go ahead. Well, okay, we found them one at a time. Okay? If you solve this crazy equation, you'll get x equals 3 or x equals negative 4. That's what you'll get. I didn't do it. That's right. That's right. Matter of fact, this is what we were doing on the first part of the homework. Everything with equations. Or it's what you will be doing if you haven't done this one yet. Okay? So it's interesting because you can solve it graphically. If you know what the graphs look like, hey guys, I can see that they go through 3, 4. By the way, the reason I knew that 3, 4 was a good answer was because of the right triangle. 3, 4 what? 5. And what's the radius of this green circle supposed to be? 5. So I said, oh, if it goes through 3, 4, then it really does have a radius of 5. And so I thought, oh, that works. And then similarly, negative 4, negative 3 works. Okay? Now, all that is great, but all that is equations. And I'm trying to up the ante here. I'm trying to show you how to solve a system of inequalities. Now, Jenna mentioned this idea of test points. Well, no, of sign diagrams. And when I say a test point, do you remember what we do? Like, yeah, you plug in, does it matter? I mean, if this is A and this is B, you pick any point you want between A and B, and they're all going to give you something that's the same sign. You guys with me on that? We've done that before. Okay. Well, now we have 2 variables. And the idea is very similar. It's just that instead of just one variable where you have a number line, for 2 variables, you have the whole coordinate plane. And instead of having a little space where we have equality, where it equals 0, here, what I'm saying is true on this line. This line is precisely the places where we have equality. We have equality on that line. Are you with me? So what I want to do is I want to pick a test point. I want to pick a test point. And you can pick any test point you want. Wayne, give me a number, favorite number. 13, very nice. Stephanie, give me your number. 13, 7. I could say that x equals 13 and y equals 7. Let me just see what happens if I do that. Now, where would that be? X equals 13. Well, here's 0. 5, 10, way over here. X equals 13 and y equals 7. There it is. That's the point 13, 7. I have a question. Is 13, 7 a solution to this inequality? Well, how do I check? Well, I put the numbers in for x and y. Where it says y, I'm going to write what? 7 is less than or equal to 13 plus 1. Is that true or false? Isn't that true? 7 is less than 14, so let's say that's true. So here's a question. Is 13, 7 a solution to that inequality? And the answer is yes. Now here's the thing. Any set of points you pick on this side of the line, you're going to get something that's true. Any set of points you get on the other side of the line, what's going to happen? That's right. Travis, give me a point that is on the other side of the line. Okay, so let's try that. So if we go to negative 5, 7, that's up here. And if I say I want to try negative 5, 7, let's just verify that that wouldn't work. Well, we'd have 7 is less than or equal to negative 5 plus 1. You guys agree that's false? Do you see what I'm doing? Okay. So all you have to do is pick one point, test it, true or false. If it's true, you know which side of the line we should shade. Okay? You know which one I always pick? Well, not always. Almost always. I almost always pick 0, 0. I love using that as my test point because it's so simple, the math. 0 less than or equal to 0 plus 1. True or false? Well, we knew it had to be true because it's on the same side as this one. That was true. But the point is that once you know which side makes these things true, we kind of shade in that direction. We say, okay, that's the graph of the inequality y is less than or equal to x plus 1. So that's how you do a two-variable inequality. Okay? Now I'm almost done. I also have to do the two-variable inequality here, the circle. X squared plus y squared is bigger than or equal to 25. Okay? So now we have to try a test point. So let me do that in this color, kind of bluish. X squared plus y squared is greater than or equal to 25. And I need a test point. Tell me what test point I want to use. Okay, let's try 0, 0. That's my favorite. I get 0 squared plus 0 squared is greater than or equal to 25. Is that true or false? That's false, right? 0 isn't bigger than 25. Okay. Now, where does that mean the solutions are? That's the trick. What's that? Yeah. So can you give me an example of a solution? Remember now, we're not looking at the line anymore. What are we looking at? The circle. So when we say the other side, how many sides does the circle have? How many sides does a pentagon have? How many sides does a hexagon have? How about an octagon? How about a circle? 2. Inside, outside. That's an old joke, but it's actually helpful here to understand. I just try to point inside the circle. True or false? Yeah, it's true that I tried it. What was the result? False. Okay? I try to point inside the circle, and it did not satisfy the inequality. So is 0, 0 a solution? The answer is no, it's not a solution. Okay? Give me a point that will be a solution. Sure, 5, 5 is a nice choice, right? If I go to 5, 5, that's up here. Okay? 5 squared plus 5 squared is greater than or equal to 25. We're going to say that is true. I knew that. So where are the solutions to this inequality x squared plus y squared is bigger than or equal to 25? Well, they are all the points outside the circle. You guys get that? Okay, now, we're trying to solve the system of inequalities. We want the intersection of these two sets. I'm going to show you the picture of the solution from the book, and it ought to make sense, I think. There you are, number 26. Do you understand how that comes about? Because we want to be outside of the circle. We also want to be below the line. And so the points that satisfy both of those look like this.